In section 10.4, we're going to look at different ways of displaying data. So we're going to look at stem and leaf plots and histograms, which basically show the distribution of data. So they're both types of frequency distributions. And so your vocabulary for this is going to be what's a stem and leaf plot, what is frequency, what's a frequency table, and what's a histogram. It's all pretty straightforward and simple stuff. So a stem and leaf plot is a data display that organizes data based on digits. So each value is separated into a stem, and if you look at these values, we're going to be doing our stems based on the tens place. Okay, and the leaf will be the ones place. So if I had a different type of data or a different size of data, I might do it a little differently. But that's what's going to be logical for this. There's nothing over 100. There are a lot of numbers that are under 10 though, so we're going to work with that. And when we go through this, I'm going to go ahead and make, essentially, it's like a T-chart. And I've got the tens place, right? So here's tens, and here are ones. So I've got 0, 1, 2, 3, 4. And the way this text shows you how to do this is to go through and organize the data into the stem and leaf. The way I personally learned was to put it in order first, which will eliminate, it would actually combine step 1 and step 2, because if you put them in order, putting them in order first eliminates step 2 in this method I'm going to show you. But if we go through and we do this, I take 14, that's got a stem of 1 and a leaf of 4. 25 has a stem of 2 and a leaf of 5. 8 and 8 both have stems of 0. So do 7 and 7. 19, 37, 39, 18, 42, 23, 4, 32, 14, 21, 3, 12, 19, and 41. So now if I go through and I put them in the right order, it does make it a little easier, because now when I'm putting it in order, I'm just working with the leaves. So the leaves in order here are 3, 4, 7, 7, 8, and 8. And when I go on to 1, I'm going to have 2, 4, 4, 8, 9, and 9. When I go on to 2, I'm going to have 1, 3, and 5. When I go to 3, I'll have 2, 7, and 9. And when I go on to 4, I'll have 1 and 2. And so now you can see, where does the data lie, right? I've got a range here from 3 up to 42. So I've got a range of 39. Where does the data all lie? Well, you can see that there are 1, 2, 3, 4, 5, 6 items below 10. There's another 6 items between 10 and 19. I've got 3 in the 20s, 3 in the 30s, and 2 in the 40s. So everything's sort of bunched up here in the first couple of tens. And that's how you make a stem and leaf plot. Okay, again, like I said, if you take the time to take the raw data and put it in order first, then when you do step 1, it will actually all be in order already. It doesn't matter, do it however you choose. Okay, now this is a two-way stem and leaf plot, or a back-to-back stem and leaf plot. So we've got the data for the men on one side and the data for the women on the other side. And what we want to do is we want to compare the ages of the gymnasts. Well, you can see that 1, 2, 3, 4 of the women are under 20, but none of the men. 2 of the women are in their 20s and none of them are in their 30s. For the men, they're almost all in their 20s, one's in their 30s. You can see that the men are older, right? So if we're comparing, you can tell very quickly looking at the stem and leaf plot that the men are quite a bit older than the women are on this Olympic team. Okay, so that's, again, using a stem and leaf plot a little bit. When we talk about a frequency table involves taking the range of your data and breaking it into intervals. Okay, so between this number and that number. The stem and leaf plot does that, but in the stem and leaf plot, the size of the interval is predetermined, right? It goes by tens. That's the only way it's set up. And sometimes that's going to work for you and sometimes it's not. In a frequency distribution and making a frequency table, you can set the intervals however you want them to be. You just have to make sure that there's no overlap so every item distinctly belongs in a specific interval. Okay, so and when we deal with representing a frequency table, typically what we use is a histogram. And a histogram is a vertical bar graph that has no gaps in between the bars. Okay, so the length tells you how many times something occurred in a given interval. And what you do is you graph the count of how many are in the interval. And when you create your histogram, it's a bar graph with no space between the bars. So let's take a look at what that looks like. Okay, so now we've got these prices here for pizzas. We got $4, $4.25, $4.50, $4.75, but you can see everything is between $4 and $6. Okay, so that's kind of narrow. And if I want to go ahead and create enough intervals to look at this data, I have to make some choices. So first thing I want to do is I want to look at how big is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations. So I don't want my intervals to be too big, and I also don't want them to be too small. So what I'm going to look at is what would happen if I went like every 50 cents. Okay, so if I go ahead and I create a frequency distribution that I went from $4 to $4.49. That could be one. And if I go from $4.50 to $4.99, and if I go from $5 to $5.49, then I can go from $5.50 to $5.99. All right, and that allows me to create, you'll notice that all of my intervals are the same size. There's no overlap. And I'll be able to clearly put these guys into the appropriate place. But remember, I'm not looking at what the actual value is. I'm counting, essentially, how many items fall in each interval. So I got $4, $4, $4.25, $4.50s in the next interval, $4.75s in the next interval, $4.25s back here, $5.95, that's up here, $5.50, that's up here, another $5.50, that's up here, and $5.75. So when I take a look at making this interval, I need a scale, and you can see that the max I had was 4. So 1, 2, 3, 4 observations. And if I take my first item, this is the $4 to $4.99, I'm just going to call them 1, 2, 3, and 4, rather than writing the price in. In the first one there were 4, in the second one there were 2, in the next one there were 0, and then the next one there were 4. Okay, and this is what a histogram would look like. 4 values, 2 values, 4 values, if I was working with doing intervals from a frequency table. Okay, now you might think, well, this may not choose enough data. Remember, if I made my intervals smaller, maybe 25 cents, You can make them too small where everybody's got like one entry. You can make them too big where everything's clumped up and you can't really see. I think this gives a pretty reasonable representation of what we're talking about.